Welcome back, Pre-Calc. I hope you're well. We are in section 4.4c today, and we're basically going to put together everything we've looked at in terms of graphing sinusoids, which as a reminder is both graphs of sine and cosine functions, as well as their transformation. So I'm going to force a pause on your screen, make sure you have everything on the checklist. Alright, so the graphing paper you got in class, we are going to use that where it says example 1, and we're going to graph both y equals sine of x, the parent function, and y equals y equals 2 sine of x. So, question for you, what does this 2 do to the graph of the parent function? It's going to stretch it vertically by a factor of 2, right? Okay, so I would like to first graph what I call the 5 important points for the parent function y equals sine of x. So, sine of 0, what is that? Sine of 0 is 0. So I have the point 0, 0. Sine of pi over 2 is 1. Sine of pi is 0. And sine of 3 pi over 2 is -1. And sine of 2 pi is 0. And we could keep going, but that is 1 period. Right after that, we just get repetition. Okay, so those are our 5 important points. So for sine, our period again goes from 0 to 2 pi, and our y values go 0, 1, 0, -1, back to 0. Okay, so those are the 5 important points. Now, if I want to graph y equals 2 sine of x, I'm taking all my y values and multiplying them by 2, right? Okay, so if I take these 5 important points, this first one, what's the y value? The y value is 0, so if I multiply 0 by 2, it doesn't change, right? So that's going to stay the same. However, if I take 1, the current y value, and multiply by 2, my new y value is 2, right? This guy's going to stay the same because it's at 0. 0 times 2 is still 0. This guy is going to move where? Down to -2. And then here, that one stays the same. Okay, so my new function looks like this. And really think about concavity. So we're going to go concave down and then switch to concave up, right? And if we were to graph another period, we'd go concave down, concave up. But for each of these examples, we're just going to graph one period, okay? Now, let's keep in mind, where was the original? What were our 5 important points? Remember, the y values go 0, 1, 0, -1, and 0. So again, parent function, concave down, concave up. So go ahead and make sure you have both of those graphs for me and label them as y equals sine of x and y equals 2 sine of x. All right, so we're going to graph cosine of x next, and we're going to do something kind of similar. We're going to graph both the parent function, y equals cosine of x, and then try a transformation as well, y equals cosine of 2x. So question for you, what does this 2 do to the parent function? So this is going to be a horizontal shrink or a compression towards the x-axis. Remember that inside our parent function is always opposite. Horizontal transformations are always opposite, and that's because all our functions are y equals. Okay, you never see x equals something. So if we were to get x by itself, we would have to divide by 2 at some point, right, to get x equals something. Okay, so that's why inside is always opposite, because we always have y equals something, which is our outside. Okay, so another way to think about this is, what is the period of your parent function? The period of the parent function is 2 pi. So since you have a horizontal compression, you're now going to have 2 peaks and valleys between 0 and 2 pi. Okay, so it looks like, can double it as fast, if you will. All right, so again, let's think about our 5 important points for cosine of x. Now, let's think cosine of 0. What is that? Cosine of 0 is 1, so we have the point 0, 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. and cosine of 2 pi is back to 1, and then we repeat, right? So make sure you've got those 5 in pencil. We're going to kind of move these, okay? So now let's go ahead and graph y equals cosine of 2x, and we said this is going to be a horizontal compression towards the y-axis, correct? So again, think about what would I need to do to get x by itself? I would need to divide by 2. So take your current x values and divide them by 2. So right here, well, let's start at 0, is still going to be 0, okay? Here I have an x value of pi over 2. Divide that by 2, I'm now at pi over 4, okay? Here my x value is pi, divide that by 2, I'm now going to be at pi over 2. Here my x value was 3 pi over 2, so if I divide that by 2, I'm at 3 pi over 4. Here I was at x equals 2 pi, divide that by 2, I need an x value of pi, right? So notice all my x values are now compressed towards the y-axis, but my y value stayed the same, right? So my new graph looks like this: concave down, concave up, concave down, all right? And then let's go back and graph the parent function again. Remember, we go 0, 1, and then my y value is 0, and then -1, and then 0, and then back up to 1. So concave down, concave up, concave down, okay? And that's one period. We could keep going with the wave. All right, so for example 3, we've got y equals 1/2 sine of quantity x plus pi over 2. So how many transformations do we have in this case from our parent function? We've got 2 transformations. So one transformation here is multiplying by 1/2. So what does that do to the parent function? This is going to be a vertical shrink, right? Since what I'm multiplying by is less than 1. So vertical shrink by a factor of 2. So I'm just going to compress towards the x-axis in this case. And then this plus pi over 2, what is that going to do? That's inside. So if you think about what would I need to do to get x by itself there, I would need to subtract by pi over 2. So this is going to shift the parent function to the left, pi over 2. Okay, so let's start with those 5 important points from the parent function. So for sine of x, where do we start? At 0, 0 or 0, 1? For sine, we start at 0, 0. So I've got my y equals 0. Then as I move every pi over 2, then I go up to 1, then down to 0, down to -1, and back to 0. Okay? All right. So let's deal with that 1/2. We said that is going to be a vertical shrink. So let's take our current y values and multiply them by 1/2. So this one's already at 0, so that's not going to go anywhere. This one's at 1, so times 1/2, I need to put it at y equals 1/2. This one's not going anywhere. This one's going to be at -1/2, and that one's not going anywhere, right? Okay, so now the last thing I need to do is take care of this shift to the left, right? So what I'm going to do is we'll take all 5 points and let's shift them to the left by pi over 2. So we should be approximately there. So my new function looks like this. Again, concave down, concave up. So again, I have a vertical shrink by a factor of 2, and I have a phase shift of pi over 2 to the left. All right, example 4 is y equals 1 plus 3 cosine of x divided by 2. How many transformations here from the parent function? 3 transformations. So let's start with the inside. I've got divided by 2, and remember inside's opposite, so you have to think, what do I need to do to get x by itself? I need to multiply by 2, right? So this is going to actually be a horizontal stretch by a factor of 2, right? What does the 3 do on the outside? This is a vertical stretch by a factor of 3. And then what does the plus 1 do? plus 1 moves this up 1, right? Okay, so again, let's start with our 5 original points. So parent function here would be cosine of x. So let's start at 0. Cosine of 0 is what? Cosine of 0 is 1. So my 5 original points go y equals 1, 0, -1, 0, +1. All right, now let's work on our transformation. So let's go horizontal first. Stretch by a factor of 2. So again, I would need to take my current x values, which by the way are 0, pi over 2, pi, 3 pi over 2, and 2 pi, and now multiply them by 2. So let's start on the outside first, since this is going to go away from the y-axis. So here's an x value of 2 pi, multiply that by 2. I need to keep my y, but x goes to 4 pi, okay? This was an x value of 3 pi over 2 times 2, now at 3 pi. This was an x value of pi, multiply by 2, I'm now at 2 pi. This was an x value of pi over 2, multiply by 2, I'm at pi. And this was 0, multiply by 2 is still 0. Okay, so there's the horizontal stretch by 2. Notice, what is your period now? Your period is now 4 pi because we have 2 pi over b. b is technically 1/2. So I have 2 pi divided by 1/2. Well, dividing by 1/2 is the same as multiplying by the reciprocal of 2. So my new period is 4 pi, just a little FYI. So now let's deal with that vertical stretch of 3. So I'm going to take my current y values and multiply them by 3. So 1 times 3 is 3. This y value is 0, so it's going to stay at 0. -1 times 3 is -3. This y value is at 0, so it stays. And then +1 times 3, go 3. So you can see that the amplitude is 3 right now, yeah? And then my last transformation is to shift everything up by 1. So I'm going to take all 5 points, shift them up by 1. We should be approximately there. So my one period of my new graph looks like this. Be real careful about concavity. So concave down, concave up, concave up, concave down. All right? Okay, so last example, I would like for you to bring this to class. I'm going to force a pause on your screen, but if it covers too much of your screen, just hit continue and pause it on your own. I would like for you to figure out what could A, B, and D be in order to produce the graph on the screen. So notice that here is -2 pi, this is +2 pi, this is 6, and that's +6. All right, so see if you can figure that one out. Once you think you've got it, try graphing it on Desmos or on a graphing calculator and see if it matches your guess, and bring this to class, and we'll talk about it. All right, see you all next time.